Hi, this is John Frennan from Colligo Marine. I want to talk to you today about Colligo duck synthetic standing rigging and one of the reasons why people say it doesn't work. And it's probably the biggest reason. And that reason is constructional elongation, or at least what we call constructional elongation. Here's the issue. When you have braided line, all of the strands are not aligned with the load. When you pull on the line, the strands want to align with a load. That is, they tend to go like this, and to try to be parallel to each other in alignment with the load. So what you have is this kind of thing going on. What happens with regular Dyneema that's not heat stretched is that the line is set like that, and you can, for instance, put a 50-foot backstay on a boat, crank the tension up to 1,000 pounds, and the line will slowly grow. And in fact, an 11 millimeter piece of Dyneema will grow about 6-8 inches over a period of about 6 months. And that's constructional elongation. It's oftentimes mistaken for creep. People think it's creep, and it's really not. It's constructional elongation. And the reason we know that is because we have the equations for creep, and we know what kind of loads it takes. What people will say in those situations, a lot of times it'll creep for a certain amount of time and then it'll quit creeping. Well, creep doesn't stop as long as the load stays constant. Creep is a material property, and that's just the physics of it. It just doesn't stop unless the load is taken off. So constructional elongation is the biggest issue with using a braided line for a constant load. You put it on standing rigging, put it on a turnbuckle, crank it down, you've got a constant load now. So one of the ways around this constructional elongation issue is heat stretching line. Now there's a lot to this we've learned over the last 12 years. We basically use SK75 Dyneema that's heat stretched, and we like that stuff. It's pretty good, and the reason is it's still very malleable, and when it's heat stretched, the strands nest together very, very tightly. That is, you can cut a piece of Dyneema SK75 that's heat stretched, and it looks like one strand with 12 cells in it. It's so tightly woven together. Now, one of the interesting things is there's newer chemistries. There's SK78, SK90, SK99. SK90 and 99 are heat stretched at the fiber level before they're braided, and then sometimes heat stretched at the braided level when they're a rope. Now, because those newer chemistries, 90 and 99, they actually have less material stretch than SK75. That's what you'll be quoted a lot by some of the rope manufacturers. But as a braided product, they don't heat set as well because they are heat set at the fiber level. So the strand is basically a little bit harder, so it doesn't nest together. And in fact, you can take a piece of SK90 or SK99 that in fact has been heat stretched and cut it, and it'll fall apart pretty good. A lot less, or a lot more than ducks will, than SK75 that's heat stretched. So that's a big test. So that means there's space between the strands to allow this kind of thing to go on while you have a constant load on it. So, and we've proven that with SK75 heat stretched, you can actually get around that. You can get to the point where you can use 4.5-inch travel turnbuckles on 9 and 11 millimeter line over time, and it just won't grow. We've got a company boat, a Shock 35, that's had 9 millimeter and 7 millimeter on it for 2.5 years now. I haven't touched the turnbuckles, and they're standard hang turnbuckles with 4.5 inches of travel. So that's important. And again, this constructional elongation is probably the biggest issue, and the newer chemistries still have a constructional elongation issue, and that's why Hampagen, the company we get the line from, that's why they're still using Dyneema SK75, and that's very important because a lot of the rope manufacturers have moved on to the other chemistries. In fact, DSM has tried to get Hampagen to do that, and they're refusing because they know the value in heat stretching SK75 and getting rid of that elongation. Not just for recreational sailboats, but for other products that they have too. So that's important. Constructional elongation is the big issue. Dyneema SK75 is the main Dyneema that is going to give you the least amount of constructional elongation, and oftentimes zero. Another sideline of that is we've when we first started doing this, we experienced a little more constructional elongation than larger diameters. That is 11, 13, 16, 18, 21. We've done some 25 millimeter boats too. The larger strands, so you have a 1 by 12 construction, so you have a pretty large strand, say in an 18 millimeter line. What we've done is we've worked with Hampagin and had them go to a 2 by 12 construction. That is where there used to be one strand, there's now two strands running parallel to each other. And what that does is get the strand size down for a given diameter of line, and that makes it nest easier too. So we effectively can have line up to about 25 millimeters that we do not see constructional elongation issues in Dyneema SK75 that's been work hardened and pulled. So it's good stuff. The constructional elongation is the big issue, and Dyneema SK75 Dynice ducts from Hampagin that's heat stretched is the best stuff going in our opinion, and we're constantly looking around for better stuff. But as a braided line goes, it's really hard to beat Dyneema SK75 that's been heat stretched Dynice ducts from Hampagin.